In the previous lecture, we derived an ample model file for the problem of computing a max-min strategy in two-player normal form games. Now we need to specify values for the set and the parameters involved. This is done in the .dat file. Let us consider a simple rock, paper, scissors game and see how to translate it in ample. First, we specify the elements of the set uppercase I that represent the actions of the players, in this case R, P, and S, which stands for rock, paper, and scissors. Then we specify values for the parameters, that is the matrix uppercase U representing the utility matrix of the first player. Ample provides a nice way to express matrices. After specifying the name of the parameter followed by a colon, the first line contains the indices of the columns of the matrix, followed by a colon and an equal sign. Then each subsequent line specifies a row of the matrix. The first element is the index of the row, while the other elements are the entries. Note that it is sufficient to put a space to separate two elements on the same line. This is the complete .dat file. Finally, we solve the model. First, we need to write the .run script. At the beginning, we need to tell Ample which .mod and .dat files we want to use. Say we call them rps.mod and rps.dat. Then, we need to specify which solver we want to use. In this case, we use Gurobi since the model we are solving is linear. And then we had the command called solve, which tells Ample to solve the model. After the command solve has been executed, the variables of the model are assigned to the values computed by the solver, representing a solution to the model. We can use the command display to tell Ample to output the values. In conclusion, we have to actually execute Ample. We can open a terminal and write the command to run Ample. In this case, Ample followed by the name of the .run file. Of course, you must be in the folder where the file is stored. As you can see, Ample calls Gurobi to solve the model and then displays the values of the variables. As expected, a max-min strategy in rock, paper, scissors that prescribes to uniformly randomize over the available actions.